So we're trying to solve a problem which appeared in one of the JEE Main exams. And what has been asked here is to find the r plus r value, where r is the circumradius and small r is the inradius. And we have been given a triangle for which we have to find it. This is an equilateral triangle ABC. And one of its sides is along this line x plus y equals to 3. And then the centroid of this triangle is at origin. So let's try drawing a picture of it, as in like this, to figure out how this would be looking like. So if I'm looking at a line which is appearing this way, x plus y equals to 3, this is gonna be my line. And of course it will be passing through 3, 0 and 0, 3. But my vertex may not be over here. My vertex could be anywhere, which I don't know. So the equilateral triangle could be something like this, right? Maybe like this, something of this nature. And the centroid is over here, all right? Now we have to find out this relation. So in general, let's try looking at what happens in case of an equilateral triangle, which is the simplest of the case, and wherein your centroid, your incenter, circumcenter, all will be at the same place, right? So if I'm just looking at an equilateral triangle and the relation there, and then there will be something which we need to know already, but let's do this now. So if you've got, this is the place which is the either the centroid or the circumcenter or your incenter. So if I'm looking at this, then what happens is that basically we are saying a circle, the one which will be the circumcircle, would be passing like this. I mean, as in it will be passing this way. And what would happen is that if you look at this, this is what will be called your circumradius. In similar manner, if you are looking at the incircle would be actually touching all these sides actually, right? And here too, like if you drop a perpendicular, this is a tangent. This is also going to be a tangent. And then you could also figure out this being 90 degree and this being a centroid also. And this could be what you call as the angle bisector as well, because this is where this is meeting, right? So now this angle is going to be 30 degree. This is going to be your R. So the relation between R and R would be, in equilateral triangle, would be sine 30 degree would be equal to R by R, right? And then you can find out R is going to be equal to sine 30 degrees is going to be 1 by 2 into R. So this is what is going to be my relation between R and R. I am supposed to find R plus R. Either I look at and then find out, basically, I could say that either I could find out 3R, that is what I can do, right? R is actually equal to 2 times R. So if I find out my R, then I will be able to find out this relation. Now, as you could see here that from the centroid or the incenter or the circumcenter, if I drop a perpendicular, then that would be actually equal to my inradius. So that is what I have to do. I have to drop a perpendicular from here to this line. If I can drop a perpendicular here, and then I find out this will be my R, this perpendicular distance. And we know that on any line, if you are dropping a perpendicular from a given point, then the perpendicular distance is given by this formula, which is ax1, right? ax1 plus by1 plus c upon the square root of a square plus b square. So in this case, my equation is simply x plus y equals to 3, right? And this point is 0, 0. So my R is going to be equal to 0 plus 0 minus 3 upon basically square root of 1 square plus 1 square, right? So I could say that this is nothing but 3 upon square root of 2. Now if this 3 upon square root of 2, I could just substitute it here and then find us that this is 3 into 3 upon square root of 2, and which will be actually equal to 9 by square root of 2. So yeah, this is what is my final answer. My R plus R is going to be equal to 9 upon square root of 2. And you could just mark one of those options which is given as 9 upon square root. Okay. So if you have any other question in this particular example, do ask me in the comment section below, and I'll be really happy to answer your queries. Thank you for watching this video.